CompTIA Cloud Plus, Modern Security Best Practices. We're going to begin looking at one of the most fast emerging and important initiatives for security today, and that is Zero Trust. Zero Trust, or ZT, is the term for an evolving set of cybersecurity paradigms that move defenses from the static, network-based perimeters to focus on users, assets, and resources. In other words, the perimeter is now each user or subject, all of our assets and resources. For many organizations, this began with a white paper in 2010 called No More Chewy Centers. In other words, our security can't be like an M&M or a Skittle with a chewy center and a hard coating. Everything is a security perimeter. Zero Trust, by the way, was intended to be called Zero Implied Trust because that's what it is. We used to trust but verify, but now there's zero implied or implicit trust. But as you can see, the acronym ZIT isn't that gratifying. So we just call it ZT, or ZTNA, a Zero Trust Network Architecture, to use Zero Trust principles to plan industrial enterprise infrastructure and workflows. On the exam, remember the initiative is often under the control of GRC, Governance, Risk, and Compliance, which could be a group, a team, a steering committee, or some other board. Zero Trust assumes there's no implicit trust granted to assets or user accounts based solely on their physical or network location. For example, the local area network versus the internet, an IP prefix, or a VLAN, or based on asset ownership, whether it's enterprise or personally owned. In other words, there's no such thing as internal or external, provisioned or non-provisioned. Everything's under the Zero Trust cloud. If there's a subject or anything outside of the Zero Trust, then you don't have a Zero Trust initiative. Also, authentication and authorization, both subject and object, are discrete functions performed before a session to an enterprise resource is established. So one thing we see going away in Zero Trust is anything that uses the TCP three-way handshake. Because with the three-way handshake, you're making a connection before you're authenticated and authorized. That's a violation of Zero Trust. So if you're using an existing VPN, it has to use Internet Key Exchange version 2, IKE version 2, or some other product like OpenVPN that you can do UDP-based. And the control plane is completely separate of authentication and authorization. Then you have the data plane. That definition was from NIST. There's also 7 tenets of ZT according to Special Publication 800-207. Number 1, rigorously enforce authentication and authorization. And this is really going to mean using robust things like Okta, ID ramp, biometrics, enterprise centralized identity management services, for example, Cisco ISE, or something else from Citrix or IBM. Number 2, maintain data integrity. We're going to use strong SHA-256 and 384 mechanisms. In a mandatory access control model, we're going to use things like Clark-Wilson to maintain integrity. We might even use AES GCM 256, which has its own GMAC or Galois MAC. Gather data for improved security. So continually collecting visualization information. That's going to involve using things like SIM systems and data activity monitors. Consider every data source and computing device as a resource. And not just that, but it's a resource with its own security perimeter, not just the hardened edge anymore. Keep all communications secured regardless of network location. And that's going to involve things like Transport Layer Security 1.2 or 1.3. 6, grant resource access on a per-session basis. So in other words, you could go up to Amazon Web Services or Google Cloud and you could create groups and users and have your own directory up there. But that's persistent access. That's not per-session based access like you would have at Azure with a security assertion. Now, of course, you can do it token-based at AWS if you use roles and cross-account roles, or the newer Identity Center, which forces you to use in that cloud directory session-based tokens. and then moderate access with a dynamic policy. Another aspect of ZT is it's policy-based. Whatever you want to write the policy in, that's your business. It could be JSON, it could be YAML, it could be something else. Zero trust is a really huge issue, and it's not its own domain on the exam. So what you really want to focus on for your questions is zero trust in a hybrid cloud and a multi-cloud environment and the technologies you would use. If you need to fill in any gaps with these technologies on your own, make sure you do that before the Cloud Plus exam. First, Identity and Access Management, IAM, also referred to as identity management. This will involve federated identity using SAML 2.0, OIDC over OAuth, and single sign-on across cloud providers and service providers. Using multi-factor authentication, for example, YubiKey, Google Authenticator, passwordless solutions at Azure like FIDO2, and biometrics. ZT likes role-based access control and attribute-based access control, so you know the conditions, the characteristics, the attributes of the subject at all times, and the resource object at all times with a robust inventory and tested patch management. You can also use a mandatory access control model, a MAC model, with zero trust as well. Network segmentation and software-defined perimeters. You could use private VLANs, another compartmentalization, but if you have a cluster of hypervisors, let's say Linux KVM or Hyper-V, then microsegmentation means grouping up those guests of Windows, Linux, and Mac OS systems and possibly running containers into their own communities or their own partitions. And then each community or partition would have its own virtual security services, like web application firewalls, web security gateways, next-generation endpoint protection, and data loss prevention engines. You want to limit lateral movement, so you want to prevent VM hopping, which is moving from one partition to another, or escape, which is bad because it's the guest escapes to the underlying hypervisor and hardware. You're going to use software-defined networking. SDN means several things. One, you have a separate control plane for authentication authorization. Then you have a data plane after that. You're going to use digitally signed API calls from controllers to all of the physical and virtual elements in the server farm or the data center, but you can even have software-defined networking at the WAN or MAN level with SD-WAN and SD-MAN. And we'll often use CSPs, other vendors, to help us with that automation orchestration across a city or a region. And then ZTNA replaces traditional VPNs, especially if the VPN does a three-way handshake. The Cloud Security Alliance gave us software-defined perimeter, and that's what Google uses in their Zero Trust initiative called BeyondCorp. So at Google, when they use SDP, the provisioned device has a X509v3 certificate in a TPM module on the device. They use a Google Chrome browser with an add-on, and they do single packet authentication to a controller in the cloud, and then mutual TLS 1.2. So Google doesn't even use IPsec VPNs anymore. Another big thing about Zero Trust is continuous monitoring and threat detection. So this is using SIM systems and possibly with a SOAR automation orchestration tool, let's say something like Splunk powered by Cisco or Azure Sentinel. Also cloud native monitoring, for example AWS CloudTrail to evaluate all your findings of every API call in the cloud, or Azure Monitor. And using behavioral analytics and anomaly detection, today AI and ML driven. ZT is policy-based, so using policy as code and automation. So for some organizations, getting to a zero trust initiative is leveraging infrastructure as code and using tools like Terraform or Ansible or a cloud-based solution like AWS CloudFormation. Policy as code often uses open source tools like OPA, the Open Policy Agent, to enforce compliance. And OPA uses its own declarative policy language called Rego, similar to JSON. So again, you can use for your policy, you could use XML, you could use JSON, YAML, you could use Rego. Amazon Web Services has a new service called Verified Access, and it has a language called CEDAR, C-E-D-A-R. And then automated remediation workflows for rapid response. That's where your SOAR system can come in, where you can have manual, semi-automated, and fully automated runbooks or playbooks. Protect that data and use strong encryption. So end-to-end encryption of data in transit, data at rest, and data in use. End-to-end encryption, E2EE, with those Zoom meetings or whatever else you're using. Leveraging the key management services from cloud providers, where you can have your own customer master keys or customer managed keys that you can use across several to many services. And then use tokenization. Data masking would be suboptimal, where you're just replacing some characters with an asterisk or whatever. You're still exposing some of the email address or the webmail address or the SSN or the credit card number. Tokenization is superior because it creates pseudo-random tokens of the data you want to protect. The personal identifiable information, the personal health information, sensitive and intellectual property. Integration across clouds, leveraging cloud access security brokers to enforce policies, to assist with compliance, to assist with data loss prevention, and to help you with your single sign-on when you have multiple SaaS providers and other vendors. And it's very popular to use API gateways. So for example, the API gateway at Amazon Web Services running a bunch of server-based and serverless things behind that, or service mesh like Istio for secure service-to-service communication. Now, this objective of the Cloud Plus exam covers more than zero trust. So we're going to go up and look at several other things that they want you to know about. For example, the Center for Internet Security, CIS, also API security and container security. Let's go up and do a web safari and give you some ideas about how to prepare for these questions. On the exam, you should be familiar with the Center for Internet Security. Number one, it has a top 18. Okay? Now, do you have to memorize these? No, you don't. But I'll give you a hint. As far as the CIS is concerned, if you don't have control number one and number two, don't bother with the rest. Because number one is knowing your enterprise physical assets, and number two is knowing your virtual or software or logical assets. So if you don't know what you have, how can you secure it? How can you protect it? So 1 and 2 are basically know what you have, okay? Evaluate, assess, have a robust inventory of the physical and logical assets. That's the top 18, very popular, but on the exam they want you to be familiar with the benchmarks. So the benchmarks are basically configuration guides and existing images of 25 plus vendor product families. Okay, a consensus-based approach to not building up your operating systems and things from scratch. So you can see in alphabetical order all of the different kind of kits they have to support all these things. You know, Amazon Linux, Apache Server, Apache Tomcat, you know, the list goes on in alphabetical order, all these different vendors and their products. So the benchmarks are kind of baseline images and virtual machines that are customized across a wide variety of different business cases, private sector, public sector, government, commercial, the list goes on and on. Benchmarks. Also on the exam, there's security for API calls. So this is the API top 10. Using APIs, which are pretty much all you do in the cloud, comes with security risk. So you can kind of look at it this way. You can have broken authentication authorization. So that's kind of one category where you just have poor authentication authorization where it's been broken or compromised. You have resource consumption. So the API call is so poorly written that it becomes like a denial of service attack. It uses up too many resources on the server side and it kind of starves out for other clients. Okay? Giving unrestricted access to sensitive business flows with the API call. Remember, RESTful APIs typically do 4 things, and we define it as CRUD, C-R-U-D, create, read, update, and delete. A server-side request forgery is a type of injection attack that takes advantage of an authenticated session. And if the API call is a highly privileged user, then you can do a lot of damage on the server side. Obviously, just misconfiguring your security, probably not using automation and orchestration like a SIM and source system. Improper management of your inventory, okay, whatever you like, your container inventory, whatever you have in your Git or your repository. And then just the unsafe consumption of API calls. Writing good API calls is an art and a science, and you may be getting the help of like generative AI now to help you write your API calls. And then there's Docker security. You could say this is container security, but for the most part we use Docker pretty much all the time. The security of the runtime, build, and orchestration of containers, usually done with Kubernetes or K8. So basically, this site, Tigera, has some good stuff about this. Unrestricted traffic and unsafe communication is a risk. Vulnerable and malicious container images. There's over 100,000 open source container repositories. So make sure that you have your repository security. Unrestricted access, okay? You should be using least privilege and separation of duties. Making sure the kernel is not exposed to unauthorized parties. And then a breakout of a container. This is not unlike a escape that you would see from a virtual machine. So we could have a guest that could do an escape into the underlying operating system. Well, that's what a container breakout is. You can hop from one container to another, or you could escape from the container to the underlying operating system. And so they provide some best practices. Avoid using root permissions, use secure container registries like AWS Elastic Container Registry, ECR, limit resource usage of each, have a quota, a limit on each container, scan your image, right, using some third-party tools, maybe something from a cloud provider. Build your networks and APIs from the ground up with security in mind. So number 5 would be going back to the OWASP top 10 for API developers. And then continuous monitoring of your container environment or visibility at all times into your Dockers throughout the entire life cycle. I hope this video was informative for you. I want to thank you for viewing.